should be showing now on everybody, on your end for everybody. We'll get going. So just firstly, just run through the agenda a little here. So I'll just give you a quick introduction to eTool, both the company and the software. And then I'm going to attempt the ambitious task of running an LCA in 10 minutes, which will probably take us 15 minutes. And then I want to show you, the key thing I want to show you today is how to actually use LCA to improve your building, so run some improvement scenarios. That's the real benefit of life cycle assessment, and I really want to demonstrate that today. So that's probably what we'll be focusing on. A little bit on reporting at the end, and then I'll give you a bit of an overview of LCA standards, just so you know what eTool can and can't do with regards to complying with those different standards. If we've still got time, we'll just open it for questions and discussions. I've sort of made myself free for the next hour after this webinar to answer questions if people want to hang around. So we'll get going. I guess first of all, why eTool? And basically, we created eTool because we were asked to actually conduct a life cycle assessment for a small development here in Perth. The developer was Earthcare, and they wanted to develop a zero carbon residential project. And we naively assumed, we were, I guess, energy consultants at the time. We naively assumed that we could find some robust, cost-effective software to conduct this assessment, and we took the job on, and we couldn't actually find anything, so we ended up building our own. That was the original, I guess, premise for eTool. So it is actually created out of a need, I guess, rather than something that we just dreamed up. And how big is this need? So this chart here is a map gives us the greenhouse gas emissions per capita for different countries and regions, and there's a pretty big range. The global average is probably, that's a log scale in the key there, but the global average is probably around 5 to 6 tonnes per person, depending on the source of the data. Where we really need to get to be sustainable is definitely well under 2 tonnes, and probably as our population actually stabilises at 9 or 10 billion, we probably need it to be more like 1 tonne per person, at the very least something under 1.5 tonnes. So for a country like Australia that, or the US, where we have an emissions per capita of around about 25 tonnes, that's a pretty big paradigm shift. So we do have a bit of work to do, and buildings play a really important job in that, or really that they're in terms of fixing that greenhouse gas issue. Around about 30 to 40% of all primary energy is used in buildings. In terms of carbon dioxide emissions, which isn't the whole story with regards to emissions, there's also a lot of methane emissions, etc. But it's predicted that 39% of carbon dioxide emissions relate to buildings in the US. And there's another quote that said that potentially it's even more than that, up at nearly 50% comes from the building sector. So depending on the scope and where the data is coming from, there's different levels. But one thing we can be pretty confident of is zero carbon buildings are a really crucial component to solving climate change. There's also some nice little fringe benefits. So this is a chart that shows that zero carbon building. The green line there, actually from year 16 in this case, is a better economic solution. So now that's a pretty ambitious design there. It's cost a lot more to build, and potentially we could have got a better payback if we'd been happy with a 90% reduction in carbon or whatever. But there's usually a pretty good correlation between life cycle cost benefits and life cycle environmental benefits. A bit about the organisation. I guess the key thing about eTool is that we're a problem-solving bunch of people. That's really the core driver of what we're about, and we just see global warming as a problem, and buildings is an area we think we can contribute a lot to helping solve this problem. Our goals, essentially, we want to provide this software free of charge for non-commercial use at least, and that's really to maximise the availability of all so everybody can use LCA to dramatically reduce global CO2 emissions, propagate the use of eTool as quickly as and effectively as possible through education, training, and also marketing. Once we're a nice profitable entity, we'll be using those funds to pump back into good stuff to help humanity and sustainability. And we also want to, I guess, lead the business community in terms of the way we conduct ourselves ethically as well. So I'll move on to the demo part of the webinar now. I've done a little bit of preparation here, and if you go to our website, you can actually there's a bunch of help videos that show you how to set up a project and set up a design. I do need to update those because we have done some pretty significant updates to the software since they were written, or those videos were recorded. But nevertheless, you should be able to bumble your way through pretty easily. It's fairly intuitive setting up a design. Once you've set a design up, there's a number of different ways you can input data, and it's really categorized into assembly inputs, which is your construction equipment, your labor inputs, etc., into building or maintaining your structure, and then your materials inputs, or your products that go into the building, and also operational energy or operational water inputs. They're the main input categories. So, for example, in this design here that I've set up, so we're going to do an LCA, a very simple little studio building today, just for the purposes of demonstration. If I wanted to add some concrete into the floor, I could just choose concrete from the materials list here. And give it a description, give it a quantity. In this case, I'll choose cubic meters. Give it a material life as well. How long could I expect that material would last before it has to be replaced? And I can also actually customize my transport distances here as well, not just for bringing the material to site, but also at the end of the life of the end of the building life for disposal, etc. So the only problem with that is I haven't accounted for any of the labour or equipment that might be required for that concrete slab to be poured. So if I was to do this manually from scratch like this, I would have to then navigate back out here and add the labour or the equipment in manually as well. So, and this gets really arduous, particularly if you're trying to determine you know, how much mortar is in a building, or you know, in a brick wall, or for example, when you get down to the nitty gritty of timber frame walls, etc., it's really quite complicated to build all those quantities up from scratch. It's a nightmare, actually. I mean, we've done that many times over, but what we realised is most of the time the components of these walls or floors or whatever the elements of the building, they're really, really similar. So what we did is we set up this thing called a template library. And if we search for floors in here, we should be able to find a concrete slab. I'll just give this a little bit of a different. There we go. So 100 mil slab on ground. And off the top of my head, I'm pretty sure this little studio had a 50 metre floor plate. And we can add that to the to our model. Now, what that did was actually added in all the inputs that were required for that concrete slab. So you can see here, it's added in 1, 2, 3, 4, 5, 7 different equipment and labour elements, and the runtime required for that. And it's also added in concrete for the floor, but also it's added in some sand for the foundations here, or the foundations of the slab. So it's a nice comprehensive template of information regarding that floor element. So what we basically do is harnessing the previous work that anybody using eTool has done to create this template library and make it a lot easier for other users to build up their materials. So once you start building your model up, you can see over on the right-hand side, there's a bit of a pie chart here. In this case, we've only put the concrete slab in, but that's 70% products, 17%. So that's 70% essentially concrete. There's a little bit of sand and I think some plastic as well for an impermeable layer there. But most of the impacts would be relating to the concrete. Then you've got some transport, getting that concrete to site, some construction, which is your equipment, and then end of life is fairly significant as well, getting it off site and to a landfill. So you can change up here the indicator that you're looking at. If you're not interested in global warming, you can have a look at how this relates to ozone layer depletion or fresh water depletion or whatever it might be. So this is the water that's required to actually produce those materials or actually transport the materials or whatever it might be. So it's the embodied water, if you like, and same for all these impacts. It's the full upstream and downstream effects of having those, supplying these materials, etc., to the building. eTool also covers operational energy, so I'm going to move on and actually let this little. I've sort of automated the for the purpose of this webinar. I've automated a little LCA, so I'm going to let that run now, and I'll just sort of talk to you while the assessment's running. So we're just going to add these templates in. This first one is some lighting and electrical fittings, which you obviously wouldn't actually go into a building before all the other elements. So this isn't necessarily in the order of the way it would be built, but you'll get an idea. So this is some plumbing installed to the slab. So before you actually get into the building, you need to put your plumbing in. This next template is just site surveys and inspections, so it's effectively just labour, and the transportation of that labour to and from the site is also included in the scope of that template. Here's the floor going in now. So I think I removed that template from the design before that we just looked at as an example, so that's being re-added now. This is the external walls, and from this point on, the design starts to become, or the LCA model starts to become reasonably comprehensive. But you'll see we'll just keep on adding templates in until we've got a really good LCA model effectively. At some point while you're adding in, so this is the windows going in now. At some point while you're adding your templates in, you might want to actually check how comprehensive your model is, and there's a couple of methods that you can use to do that. You can just browse through the templates that you've added, and I'll show you that in a minute. But we also have this thing called a completion report, and I'll also run through that. So that's a really good, I guess, check sheet to ensure that you've considered everything in your LCA model. eTool also, and this is our revenue model effectively, is we provide a certification service, and that enables you to be confident that your inputs are correct, and we charge a nominal fee to run through your model, make sure that it is complete, make sure that your entries are accurate, and then issue a certificate. So we're now actually adding in some operational energy. So we actually have templates that relate to operational energy, not just materials and construction. And we'll see in a minute that the overall life cycle impacts of this little building are quite dominated by operational energy. That will change depending on what electricity grid the building is connected to, and you can run those scenarios in eTool as well, which makes it pretty handy. So, for example, if a building was located in, say, Portland in the US, or Hobart in Tasmania in Australia, the grid intensity for that location would be a lot lower. So you definitely have a lot bigger impacts associated with the materials in comparison to your operational energy. So we're just going to run this, what's called a completion report now. And this is that checklist that I was talking about. Whoops, let's go back to that. This is that checklist that I was talking about, where we actually look at the elements that we feel we should have added into the building, or the different categories. So you can see here straight away that we actually haven't considered water heating yet in this building. So we need to actually go and find a template for water heating, if there is one, which there is. Cooking as well. Swimming pool, not applicable for this one. Water pumping and bores, potentially not applicable, but this water supply and wastewater treatment would definitely be applicable, and I think most of these things won't be applicable for this as well. Once again, we can see landscaping hasn't been considered at the moment. That's probably out of scope for this little assessment, so I'm not too worried about that. And we can just scroll down here and have a look at what's missing. So I'm just going to add some of those remaining items in now. And this is sort of in fast forward because I prepared this earlier, but it gives you an idea of how the software works. Okay. So there's the cooking template going in now for the occupants of the building, and hot water's going in next. This is our water supply and treatment. We've just got a template for average residential water supply and treatment. There's some little items here that we're adding in, so communications infrastructure, which is just a little bit of wiring, etc. So we hope now we've got a fairly complete model, and I'm guessing that some of you are asking, how does eTool know how much energy or water this building is going to use? So I will just run through that really briefly. So there are some sort of nice little smarts in eTool where when you're setting your design up, you actually nominate the size of the design. And this would depend on the type of function that you've selected for the building. So in this case, it's a studio family residence, so we know it's residential, and these attributes are linked to or customized to this type of function. So you can also use eTool for assessing a road or a bridge or a stadium or a commercial building, and these attributes that the user interface asks you to enter relate to that type of function, I guess. And so we know from here that we've only got one occupant, and that's what we're planning, or the plan is for this building, is to have one occupant. If we go and actually have a look at these operational energy items, we can see here that we just jump in here. We've actually got, rather than having a straight figure typed in here, we've actually got a formula. So you can actually type these formulas into the eTool entry points, and these are all just in-housed for us for this purpose. They're all in-housed in the template, so you don't even have to know what the formula is. But eTool uses these formulas to calculate the demand for electricity that relates to, in this case, computers and other entertainment. So it's taking that occupancy. It's also taking the number of dwellings. So in this case, it's just one. So this relationship's just a single relationship. But what this does is it increases or decreases the power consumption depending on the occupancy, and it's not necessarily a linear relationship between 0 and a certain number. In this case, the baseline is 425. That's megajoules per annum. So, and it's the same for all these different energy items. Hot water is a little bit more complex. That's going to take into account the input water temperature for the project. So if you're in a really cold climate, you're going to use more hot water or hot water energy, despite the fact that you use the same amount of water because you have to heat it up from a lower temperature. And the inverse is obviously applicable for warmer climates. So depending on what you enter into eTool when you're setting your project up, it's going to recognize that and actually adjust these values for the templates to give you some reasonable figures. Now, eTool isn't, there's a fair bit of sophistication in these estimates, but there's no reason why you can't use an even better external tool to model your hot water demand or model your, for example, if you're using eTool, we're going to put a PV system on this later. You could actually, rather than use the eTool default for the PV generation for that size system, you could use an external tool to model it really accurately. So, and then you just override the assumptions that eTool's made. So I just want to talk a little bit now about the actual impacts in this building, and then really get on to how we can improve it. So you can see here that we've got 72% of the impacts relate to energy, which is the operational energy during its life. There's quite a lot of maintenance in there as well, 11% relating to maintenance of the building, which is really just materials and labour and equipment. A little bit in transport, that's transport of materials to the site. Some products, which is your materials initially. At the end of the you've also got some water, which is reasonably significant. It's 4% of the life cycle. So it's delivery. This is carbon impacts. This is delivery of the water and also processing of the water actually emits a lot of greenhouse gases, and over the life of the building, it's actually quite big. And end of life, which is dealing with all your materials, etc., landfilling or whatever it might be, is 3%. So it's reasonable as well. I guess the first thing we'd probably want to look at is how we can reduce these energy impacts. So if we actually go in and have a look at the detail on the operational energy, we can see I've modelled this building for the Perth coastal climate, which is probably the best climate in the whole world to live in, and you could live in a tent most of the year and be quite comfortable. So the thermal control, the actual heating and cooling for this building is really, really low in comparison to the other energy items. And now we can change that, and I might just run that as a quick scenario. If this building had a much bigger heating demand due to being in a colder climate, we could actually just go in here and bump up the heating demand, and we'd probably see a reasonably big kick in the demand relating to heating and cooling. Yeah, you can see that jump from, I think it was 7% or something, or maybe even lower before it's jumped up to 17%. And that obviously also depends on the method that you're using to actually supply that heat. Anyway, so moving on, hot water's pretty big. Refrigeration's also big. Looking here, laundry and bathrooms reasonably big. Entertainment's quite big. And then there's some other items in there. But what we might do is we might run a scenario to try and reduce this hot water energy. So we've just assumed basically BCA compliant hot water use, if that makes sense. So we might jump in here, and the whole, I guess the power of eTool isn't necessarily in. You still need to have this, I guess, investigative, motivation. You know, so eTool helps you identify the hotspots. It doesn't necessarily tell you exactly how you're going to fix them. There are some things that really help with that, but the whole value of eTool is there's a nice quote by, I guess, he was an inventor, I think, in the US called Charles Keating, and he said, a problem well stated is a problem half solved. And that's really what eTool does. It just highlights exactly where your impacts are in this building over its whole life cycle. And then from that point, making changes to really help reduce those impacts is so much easier. You're no longer guessing whether a certain strategy over here is worthwhile versus something else that you could do in the building. So what we're going to do is we're going to use eTool what we're going to do is we're going to copy this design, and we're going to use eTool to basically run improvements on our copy, and then we can go back and actually check how much we improved the design. So let's just try that now. Just copying it now. We're going to give it a name that we know we're going to recognize. So this is our improved design. Just there, I selected what my base design was, so I know what I'm actually referring to. And then I'm just going to, okay, so I've just started a new recommendation. So we've got this, I'll just go back out here and have a look at this. So I'll show you this. This is a recommendations tab in the eTool console. And really what this enables you to do is record the relative benefits of the improvement scenarios that you're trying to run. So we're going to, we identified that hot water was the big one, you know, that was one of the ones we wanted to tackle. So let's just have a look at that. and we're going to call this, what we might do initially is just even put some low flow shower heads into this building. So that's a bit of a no-brainer in terms of reducing your hot water impacts. And we'll do this manually initially. So I can just put this in here myself, and I'll probably call this an energy efficiency item in terms of the category of the type of recommendation. I'm going to save that. If I then navigate back into that recommendation, it'll give me a little record button. This is a really neat feature. When I hit that, it actually, eTool actually records all the current total impacts of the building, and then gives me a starting point. And then any changes I make, once I stop recording, it'll give me the difference in terms of the saving that I've actually made. So let's assuming we're going from a sort of BCA compliant, so code compliant shower head in a residential setting in Australia, which is 9 litres per second, I believe. And let's assume we reduce that down to 7 litres per second. So that's really going to have a direct effect on the majority of our hot water use. So it might only be 80% of the hot water use that's directly used in showers. So I'm just going to do a quick formula. Or let's assume it's just going to affect 100%. We put low flow fittings through the whole building. So it's basically going to be 7 over 9 times the existing demand that we had. So a little bit of simple mathematics there. And that's going to reduce our hot water demand by that correct figure. And then we probably should also model the water reduction. So it's a little bit clunky, I guess, in that that's not happening at the same time for this particular template, the way we've set these up. But there's no reason why we couldn't set a template up to, bring these together. So water supply is going to drop by the same figure as well. And also the wastewater treatment for the showers. So we've effectively just thought in our heads, okay, how can I reduce that hot water demand? Low flow shower heads is going to be a good option. We've got some assumed demand there, and I'm just going to reduce that demand for that water, the water treatment and the energy related to the hot water by the relationship between the old and the new shower head. And now I'm going to stop recording, hit the stop recording button, and that's going to actually calculate what change that made to the building or to the life cycle impacts of the building. We can see here for each of these environmental indicators what it did. So no change initially, so it's no more or less intensive to put those low flow shower heads in. And potentially maybe we should have allowed for a little bit more materials. Maybe the low flow shower heads use a little bit more materials. I'm not sure about that, but we could have done that if we wanted to. And then we've got after the first 10 years, we've got a 1 tonne or 1,000 kilogram CO2 saving. And then over the life of the building, it's a 7,466 kilogram saving, basically. So I'm going to save that. I'm now going to let my little scenario run, and I'll just talk you through what I'm doing. So we're going, this next recommendation is also to reduce hot water, but this time we're going to focus on the technology. So we're going to actually implement a solar hot water system. And in this case, we're just going to actually delete the old template out and load up a new template for solar hot water. so the old template was a standard gas hot water system, I think. So this new template's going to have the solar hot water in it. So I'm just going to find the old hot water template in here and delete it in our templates list. That's the gas. This is the old hot water system that we want to remove. And then find my solar hot water system. So obviously going to have a very different energy profile. And add that in. So we've just recorded that. That was a lot. I'll just go back in here. So that was a much bigger saving. So in terms of that hot water, whoops, a much bigger saving, but at a greater expense as well. So if we actually, we can actually even look at the life cycle costs of what this means for us as well. So this is in dollars per occupant per year, but it gives some relative figures here. So you can see here that low flow shower heads gave us quite a good environmental improvement, and they didn't cost us anything to implement. It's pretty much you can get the low flow shower heads, we've assumed here anyway, for the same price as the normal shower heads, whereas the hot water system is actually going to cost you quite a bit up front. You do see an economic payback on that within 10 years, so you're back in front before the 10-year period, and then over the life cycle, it's of the building, it's quite positive as well. So that's the other thing. You can use eTool to say, okay, well, how much bang for my buck am I getting in terms of how much do I have to spend economically to get the same amount of or a standard amount of carbon improvements. And I'd say in this case, although low flow shower heads is, well, obviously low flow shower heads is a lesser saving in terms of greenhouse gas savings, it's not costing you anything. So you would always, I guess, implement this one before the solar hot water system if that was your focus, to get the best bang for buck in terms of environmental savings for the least amount of money spent. So I'll keep going now with the recommendations. We'll just run a few more so you get a feel for how these work, and then we'll have a look at some reporting after we've done this. So the next one I'm going to, I should just discuss this. So those first two recommendations that I ran them from scratch, but we actually also have this library of recommendation ideas, if that makes sense. So in here, I'll just go back out and show you this because it's quite neat. We can say add from template, and that's different from the building template. This is a recommendation template. And we can choose these different, I guess, improvement categories. So let's look at energy efficiency. And there's all these ideas about how you can reduce the impacts of your building. Some of these, when you run them, depending on what the carbon intensity of your grid, etc., it might not actually be a benefit to that particular building. So we're sort of assuming here that in a lot of grids, it would be better to use gas for cooking rather than electricity, because you're burning it at the end use source rather than wasting 70% of the energy somewhere in the electricity grid. But if you're on a low carbon grid, this if you actually modelled this, you'd actually get a negative improvement, if you like. You get an increase in impact. So it's certainly in terms of carbon anyway. So you just, these aren't necessarily definitely going to be fit for your building, but it does give you an idea of things you can consider doing to improve your building. So we saw in our sort of impacts there, in the operation energy, that appliances was really quite big. So we're going to have a look at what high efficiency appliances might do for the building now. So I'll add this to the design. And then we'll navigate back in there, hit the record button. And there's actually a template for high efficiency appliances as opposed to just normal appliances. So we're going to run this and see what happens. And now this is not a building integrated, it's not a building integrated, I guess, appliances aren't building integrated. So we've been pretty conservative with the way we're going to model this, or this template is quite conservative, and it only assumes that you get this saving for the first 5 or 10 years of the building's life, after which time the appliances are going to be replaced, and you can't really control how the occupant replaces those appliances. So we're being pretty conservative in our savings figure here. That and potentially there's a lot more to be saved here if the occupant was on board with this. So the other thing, with all the templates in eTool, what we're really talking about is this is how an average occupant would use this building, not necessarily a good occupant or a bad occupant, but an average occupant. So it's almost like if you built this thing 1,000 times, and you averaged all the energy use over those 1,000 buildings, then we think that these figures would be quite correct. So obviously on a case-by-case basis, though, there's going to be pretty big standard deviation due to occupant behaviour. And I guess once more, if you're on a really low carbon grid, then the materials would be the dominant impact. So that would be the area which would be, so effectively your assessment would probably be more robust in terms of overall impacts if you're on a low carbon grid, because everything would be wrapped up in materials where there's actually more surety about what's actually going into the building and being used. So we're now going to add some photovoltaics to the building, and we're actually going to increase the occupancy to 2. So we're going to actually add enough photovoltaics to power the building with 2 people in it, rather than just 1. And this requires a little bit of tweaking. We just need to change the size of the system a little bit to make sure that overall the whole building's going to be zero energy. And actually, in this case, we're adding enough photovoltaics to export enough power that you get quite a big credit in terms of what you're exporting and reducing somebody else's reliance on fossil fuels. And it's actually building that, it's actually giving you a net result for the whole building of zero carbon. I'll talk a little bit about the standards and how that should be treated at the end of the session. So the next recommendation I'm going to run is a material swap recommendation, and I'll probably leave it at that. We could go on and on. There's lots of different ways we could improve this building, but this is really just for the purposes of demonstration. So I'm going to replace the concrete with a high fly ash content concrete. So I'm going to hit the record button. We've got this little feature in eTool called a bulk swap. It's just up, and that allows us to, you can access it. I'll skip through that really quickly, but you can access it from the home screen of the design. And while I'm just searching here for the materials with where the name contains concrete. So I'm just searching through all the materials in my design. I can see I've got my concrete from my concrete slab there. I'm going to select that. And that went a little bit too quickly. Just let me show you what I did there. So here's the bulk swap button. Whoops. What happened there? Okay, here's the bulk swap screen. So I'm going to search my materials here, and you can search through and find your materials by any kind of name you want. So here was the, there's some foundations that I missed, which is good. So we can run this one as well. So we've got the footings. We want to change this to high fly ash concrete. So we're just going to scroll through all our materials here. This is so 1% reinforcement by mass, and we'll go for a pretty solid fly ash blend, 50%. And down here we're getting a little graph to say, okay, well this was the impacts of these materials beforehand. This is the impacts afterwards. So we can see there's definitely a saving there. It's only 400 kilograms of CO2, which over the whole, I think originally it was 200 tons or something of CO2 over the life cycle of this building. It's not a game changer. It's not a silver bullet, but it's definitely a saving. So we'll apply that change. And the bulk swap's pretty neat in terms of looking at the different impacts of those different types of concrete mixes or whatever it might be. You can change the recycled content or the end of life recycling rate of your permanent materials. So things like steel, aluminium, copper, etc. You can run lots of different scenarios in the bulk swap to see how those things are affected. You can even change how a material is being disposed. So you can do that on an individual basis for each entry, or you can do it in the bulk swap. But so I'm just going to stop recording that concrete swap now and see how much savings we ended up with. So just over a tonne of CO2 saved, just there. I'm going to save that. So I'm just going to run some reports now, just to show you some of the reporting functionality. So what we've effectively done in this building is, so I might just bring the original building up and we'll look at these side by side. Just have to rearrange my windows a little bit here. Okay, so on the left-hand side, I have the original design that we completed in the first part of the demonstration. And on the right-hand side, I have the improved design. And just sort of focus in on this pie chart and the actual design summary table below it. So what we have here is we've actually got, you can see in terms of comparing these different elements, we've actually got an increase in the products. Okay, so we've got an increase in the impacts relating to the initial products And you might be asking, how is that possible? We reduce the intensity of the concrete, and every other recommendation that we ran was a positive thing as well, but we've somehow increased the impacts relating to the products, the initial construction products. The reason being is we've added some, we've added some things that have had a bigger impact in other areas of or other life cycle phases of the design. So one example was the solar PV system. That's quite environmentally intensive initially, but it gives you a really good saving over the life of those panels or that system. So that's why we've seen an increase in the products, but overall we've seen a big decrease. So I guess that's the other thing is that's the other nice thing about eTool is any of these recommendations that you run, you're actually accounting for those impacts in every single life cycle phase. It's the nice thing about LCA, not just eTool. So yes, you're getting a benefit over here, but there's a trade-off here, and you have to make sure that the net positive outcome of that trade-off is, or there is a net positive outcome of that trade-off, so and LCA enables that. So we've seen a little increase in products here. The recurring's gone up a little bit as well, which would relate to things like the replacement of the hot water system, which is only in the design on the right, and also the replacement of the PV system. I think the design life of this building is 50 years, I think, that we've assumed. But then you can see in the energy area here, there's been an enormous drop. So we over-specified the size of the PV system to account for the possibility of there being 2 people living in there. What that's meant is that the building's exporting a lot of energy if there's only 1 person living in here, which is the assumption that we've sort of gone back to. That actually, the way we've accounted for it in this assessment, that's actually leading to a credit, if you like, being applied because you're reducing somebody else's reliance on, or this building is reducing somebody else's reliance on fossil fuel-based energy on this particular grid. And then the water is there's a little bit of a saving in the water over here on the right, and that's because we had the low flow shower heads. End of life is pretty similar. And then the product reuse, we actually get a bigger credit on the right because some of those products that we've implemented can be recycled. So you actually get probably quite a big credit for things like PV because silica's got quite a lot of value. Same with the aluminium frames, etc., which is why you get an increase in terms of reuse credit at the end of the building life. So we've ended up with a net negative carbon figure for this building. Now that does assume that you can claim a credit for exporting that energy back into the grid. As I said, I'll talk about the different standards and how that should be applied at the end of the session. But you can change that in eTool. You can just go and recategorize how you want your exported energy treated, and that'll change for you. So we'll just go into a bit of reporting now. The first thing I might do, and we probably should have actually done this before we ran the recommendations. So we'll go back to the base design. And one of the first reports I often run after I've created an LCA is this top impacts report. And I'm always concentrating on global warming. It's really my sort of passion. I really think that's our biggest issue that we need to solve at the moment. I really hope in 10 years' time we're focusing on things like water depletion and toxicity, etc. I really do. But I'm probably not going to rest until I'm very confident that we're going to solve this or stabilise climate. And at the moment, I don't have a lot of confidence the way we're tracking. We all need to work on that a bit more, I think. But so we're looking at this. So concrete's the biggest single material impact, followed by steel. That would probably be the steel covering on the roof. But there's obviously there's a lot of recurring here, so it might be steel in the appliances, etc., in the building as well. We'd have to look in that a little bit more detail. Timber, again, quite a lot of recurring, not so much up front. So there's obviously some timber in there that's recurring a lot. It might be the cladding or something of the wall. And then we've got the other thing, yeah. So the reason that I think there's only one replacement of the timber, but you can see the end of life impacts of the timber are way bigger than the start of life impacts. So this is the Oz LCI database or the Australasian database that we use to run this assessment, and the way we account for end of life for timber in Australia is we assume that it actually anaerobically digests and creates methane, which is leaked into the atmosphere. So timber is actually more intensive at the end of life than at the start. And there's a bit of, you can actually change the end of life scenario for timber, so you can have a look at what might happen if it was combusted instead of landfilled, etc. But this gives us a bit of an idea of that's why this recurring energy is so much, because halfway through the life we've probably reclad the outside of the building, and then we've had to put that timber into the landfill. And so rather than that being an end-of-life category, it's actually occurring halfway through the life. Those impacts are being allocated. Carpets is pretty big as well. What else do we have here? So this is the roof covering. Plasters quite big as well. So anyway, it gives us an idea of how the materials relate. And then we look at equipment impacts in this table here and operational impacts here. So it's just a different way of displaying the data. We can see we're pretty on the money with the way we kind of focused on the recommendations. We didn't tackle thermal control. We could have had a look at different types of heating sources, which is where the big impacts were for this category. So the first thing I would have done is probably move to a biomass source for heating, which would have dramatically reduced the carbon intensity of this building. Something like a wood heater or a pellet heater or something like that. So that's one report that you can run that gives you a fair bit of useful information. There's another report which is really handy at the end of the building life, which is the life cycle assessment report. And this is something that you would deliver to your customers, I guess, if you're using this in a consulting capacity. So what we're doing here is comparing our base design to a benchmark, which is basically an average dwelling for Australia. And I'll just flick down to this one here. So this is base design is the yellow. Benchmark is the yellow, base design is the green, and the dark green is the improved design. So these categories are embodied impacts here, operational impacts, and total impacts. So you can see overall we've got a really good saving between the benchmark and the final design. The base design was a tiny saving against the benchmark, but not much. And this is per occupant per year, so the size of the building is kind of accounted for nicely by the functional unit that we've chosen. And then we can have a look at the detail in terms of the embodied impacts, so fittings, assembly, walls, etc., through there, and also the detail of the operational impacts. So you can see that solar generation has really dwarfed all the other single categories here in terms of impacts, but the biggest one for us initially was water heating, followed by equipment and appliances, etc. This table here shows us how our recommendations affected the final design. Once again, you can see renewable generation is the biggest factor here, but that was actually hot water as well as the PV. So it wasn't just PV, it was hot water as well. There was a little bit in energy efficiency because we put the high efficiency appliances in and the low flow shower heads, and then there was a little bit in terms of the concrete replacement as well. And as I said, if you had a design on a different grid, then that relationship between what those different recommendations would have done to the building would be different depending on the carbon intensity of the grid. And we've run this report for carbon. You can run it for other indicators if you want. Goes into a lot of detail now, which sort of gives you, I guess, probably what would be considered a executive summary for a full ISO 14044 compliant report. It gives you some base information, but nothing too detailed. There is this chapter at the end of the report on the recommendations, and all those notes that you made in your recommendations are actually documented here. So this is why it's quite useful to give this to somebody. If you're using eTool from a consulting point of view, you can actually use, they can actually read this report and say, okay, well, why is, for example, this one here, why are the photovoltaics being considered? And there's a description here about why they're being considered, a little image there as well. So it helps them put it into context. So that's the LCA report. I can see I'm running out of time, but for those that can hang around, I'll just run through some of the other reports. You can run a report on, I won't run it, but you can run a report on annual energy costs, which is quite handy. There's the impact time series report, which I showed you right at the start, where it actually had that chart which showed how the costs were comparing over time. So you can run that report. You can also run that report for carbon, so you can see how the carbon of the two designs are comparing over time. And what you'd find if we ran it for this design is initially the carbon would be bigger in the improved design, but then over time would very quickly pay itself back due to the operational energy savings. This emission certificate's like a really it's a summary report that just shows the performance of the design compared to the benchmark. This one's not actually running at the moment, the LCI comparison, but the idea of that is you'll be able to run your assessment using different background databases. For example, it might be EcoInvent or the ICE database or something like that. And then you can actually see how the impacts of the design compare using those different databases. So we'll hopefully be re-implementing that in the next 6 weeks or so. It'd be quite a handy thing for the LCA practitioners amongst the audience. This recommendation summary chart's just really what I showed you in the life cycle assessment report in terms of that waterfall chart to show you how the improvements related to each other. So there's probably no need to run any more of those reports to demonstrate. Gives you a bit of a rough idea. The other thing that pretty much sort of wraps up the demo side of eTool, I guess. The other thing I should mention, there's a whole heap of new reports that we'll be releasing probably in the next week. Just some really neat little reports that help communicate the effects of your design. So it might be that we can run a little infographic that talks about the carbon that you've saved and what that equates to in sort of trees being planted or cars off the road or whatever it might be. So there's some new reports coming. So I guess watch this space with regards to the reports, and some more technical reports as well, like radar charts, which allow all the different indicators to be reported in one chart. We're even looking at introducing a Sankey diagram to show how the impacts are distributed within the design, so that should be coming as well. So the other thing I wanted to talk about was the different LCA different standards that relate to life cycle assessment. So this is kind of dry, but it's probably not a bad idea to run through this. So I'm just going to throw this little agenda up on the screen, which was my notes for this. So So it's just this section here that I'm going to be talking about now. So the first two standards that I wanted to discuss are ISO 14040 and 14044, and they're really quite complementary standards, and they're the core standards for life cycle assessments. Life cycle assessment principles and framework, and the next one is requirements and guidelines. So that's 14040 and 14044. So these standards are really the core LCA standards that all LCA practitioners need to be aware of. And if you are using most packages, most LCA packages, which might have more flexibility than eTool in terms of being able to do a life cycle assessment for not only a building but also a car or a book or whatever, then you probably have to have a much deeper knowledge of these standards to ensure that your goal and scope and everything are actually well understood. So eTool sort of locks you into one methodology for running your LCA for the building, but that also enables you to be more streamlined with the way you run your LCA. So it guides you through that methodology, I guess. The next standard I've listed there is 14025, which is a product environmental labelling type 3, otherwise known as an environmental product declaration. So there's different ISO standards for product labelling, and this is, I guess, the highest level, the most comprehensive type of product labelling is what's called an EPD, Environmental Product Declaration. Those of you who are joining us from Europe would probably already know about EPDs because they're gaining a lot of traction there. The rest of us may have heard of it, but they are also gaining traction elsewhere in the world, which is good to see. I'll talk a little bit more about EPDs in a minute. The next standard there is ISO 14067, which is a greenhouse gas carbon footprinting standard. Now, so I should mention, I'll just go back to ISO 14025 for a second. eTool isn't going to be a good package to run or to try and get outputs that will enable you to generate an EPD. EPDs are more of an input into eTool. So it's really at the product. You're doing assessments at the product level. eTool is really focused at the building level. As far as ISO 14067 goes, you could run a compliant report in eTool or a compliant set of outputs in eTool for carbon footprinting for a whole building. But again, you wouldn't want to run that for a single product. There's better packages for that. So 14067 is this carbon footprinting standard. There's a couple of standards that are very, very similar. One is PAS 2050 and the other one is the Greenhouse Gas Protocol. Now they've tried to align those standards while they developed 14067 fairly comprehensively. And what you'll find is 14067 is probably it's almost like a core set of requirements, and the other two standards go into a little bit more detail on how you should account for various things. So and I talked about earlier about whether we should be claiming a credit for feeding electricity back into the grid. Now, in order to meet all those standards in terms of carbon footprinting, PAS 2050, 14067, and also the Greenhouse Gas Protocol, providing you're not double counting, that is okay. Now, what that means is that, so you have to ensure that you're not claiming a credit for energy that you're using in the building due to rooftop solar, if that makes sense. But then also claiming a credit for feeding rooftop solar back into the grid. So if your grid mix accounts for rooftop solar, including your building, then you can't claim a credit for feeding that back out. So that's, and providing this is providing you're not reporting a retrospective design here. You're actually reporting a new design that's going to be added to the energy mix, if that makes sense. Then I think my questions about this are that the way we're conducting our assessments in eTool and claiming that as a credit would still mean that you're not double counting. If you start to run scenarios in eTool where you're looking at future grid intensities and you're claiming a credit, I think that would be wrong because the future grid intensity will rely on the PV that is on that building. So that's a bit of, I guess, technical stuff there for those that are interested in that area. Get in touch with me if you want more info on that, because it's quite a contentious area. The next one is EN 15804. Now, this is a European standard that it takes the EPD standard, ISO 14025, and it applies it to building products. So 14025 can be, you can do an EPD for anything, like I mentioned before, a book or a car or whatever. 15804 says, you know, it really defines the requirements if you're conducting an LCA for a building product. It's a great standard. There's still some things that I need to iron out, I guess, in that standard, particularly around end-of-life scenarios for products. However, it's a really good standard, and it really provides a level playing field for reporting building products. Internationally, I think. I'm 99% sure this is going to be the standard that everybody refers to internationally for reporting EPDs of products. That's been developed in close. 15804 has been developed in close consultation with the Eco EPD scheme in Europe, and that's a conglomeration of about, I think it's 17 EPD program operators, and they're aligning all their product category rules for building products and also aligning it with 15804. So you can probably be pretty certain in 5 years' time, if you pick up an EPD for a building product, it'd be very unlikely that it's not going to be compliant with 15804. And that's really, really good news for whole building LCA, because it means we're going to have this great database of consistent, comparable product data that we can use for our whole building LCAs. That brings me to the last standard, which is 15978, and that's put together by the same technical committee that developed 15804, and this is it's a standard for assessing the environmental performance of buildings. It's once again really, really comprehensive standard that I think gives really good guidance on how to develop life cycle assessments of buildings and report that assessment. We recently brought eTool into compliance with that standard, which also means by default we comply with 14044 and 14040 in terms of our outputs, which is really nice. You would still, if you wanted to develop a full LCA report that's compliant with those standards, there's still a fair bit of work you have to do outside of eTool in terms of report writing, but that's consistent with any other LCA package that you come across that I'm aware of. And we are looking at trying to automate a lot of the report writing in eTool, and it's something that we'll probably do coming up, but to make that job easier. But certainly the outputs of eTool, and there's actually a tab in the eTool screen here called EN 15978, and it gives you your impacts per life cycle stage as required in EN 15978 standard. So for those that are joining us from Europe, I'm sure you would have heard of this standard, and eTool's definitely ready to rock and roll in terms of delivering on that. So yeah, and I guess the other thing I should mention about that standard is it's part of a bigger project to put together standards for assessing the sustainability of buildings, not just the environmental performance, but also the economic and social performance of buildings, and which is pretty exciting. I mean, there's a plethora of rating systems, etc., out there which define sustainable buildings. There's a lot of inconsistency between those different systems, and putting this standard together hopefully will bring a lot of those different rating systems will allow them at least to refer to a standard that will hopefully align a lot of that thinking, which would be great. So that's the overview of the standards. What I'm going to do is throw it open to everybody at the moment, but you can give me 5 minutes. I've just got to nip off to the bathroom, and then I'll come back and let you know when I'm back, and we can answer questions. I can answer questions, etc. So looks like I've still got everybody online, so I couldn't have been too boring. Hopefully, I'll be back in a sec, everybody. I'm just going to unmute all of you.
That is, well, no, they don't contribute to that. And they forget. It is a, yeah, it is an optional extra. Yes.
You can type though. That red arrow there might show. Am I supposed to write message here?
Hi everyone.
Keeping an eye on them, they're about to blow off. Yeah. As they get dry,
Okay, hi everyone. I think there's still quite a few people on mute. You might have to unmute yourself. Just got a question here from Noi. How should eTool be used to account for existing buildings or structures, such as in a renovation? Good question. I'm getting a bit of feedback at the moment, actually, so I might put everyone on mute again. If you've got questions, please please type them into the chat and I'll answer them that way. I think it might be better because I'm just getting a bit too much feedback and it's a bit distracting. So to answer Noy's question, you can definitely use eTool for existing buildings. So so rather than building your LCA model up from scratch, you would only add the templates in that relate to the actual renovation, if that makes sense. And the design life that you'd assign to that is the extension of design life that you're expecting to gain out of that renovation. You do have to make a decision about whether the building was definitely going to get knocked over versus renovated, or whether it's just a renovation. But there's either way, you can definitely account for all the impacts that relate to that renovation pretty easily. We've actually done it on numerous projects as well. Interestingly, we've got this rating system that uses life cycle assessment within eTool. That's what the emissions certificate's about. And there's like, it's a metal system, and the highest rating is a platinum medal. We've only ever awarded 2 platinum medals in the history of eTool, and they were both renovations. So all the structure's maintained, which means your embodied carbon's quite low, and then the operational energy can be dealt with through efficiency and renewable generation, etc. So that is how those buildings actually achieve those platinum ratings. Can you change the transport data to reflect products purchased from overseas, for example, a modular building from China? That's a question from Amy Young. Yes, you can. So I'll just actually run a little scenario. Let's just jump into a category that doesn't have anything in it. So modular buildings it's a bit hard to apply. You can definitely apply a transport distance for all the materials that relate to that modular building, if you like. However, it just depends on how you want to run it. There'd just be a little bit of customization as you work through that template or whatever. But I'm just going to show you for a generic product how the transport is calculated. Actually, I might change it to something that's a little bit less intensive than aluminium. So we'll go for something like maybe ceramics would be a good one. So let's just have a look at, and just for argument's sake, say we're bringing in 1,000 kilograms of tiles, and let's give it a material life of 5 years. So there's these default transport distances here. So this is the new product to the site. We're assuming that it is actually imported. You've got C distance here of 10,000 kilometres, and then articulated truck of 112 kilometres. But let's just save that initially, and we'll just have a look at the impacts. So you've got products, transport, and then recurring. So we're assuming that there is actually, and there's probably a minimum or a maximum design life for the tiles, which is why it's recurring, despite the fact we put the 100 years in there. There's a couple of little things in eTool that stop users from cheating the system, if that makes sense. But this transport distance here is what's been allocated based on those defaults. If we wanted to decrease that and say, okay, well, what happens if we're just bringing it from a local producer that actually mines it and produces those tiles really locally, and they're only 150 kilometres away, and add that in, and we'll see this transport distance over here, impacts over here, the 336 kilograms. We'll see that change. So you see that dropped from 330 kilograms down to 57. The transport question actually related to bringing things in from China. So assuming we're talking about Australia here, you might assume that the first leg of the transport is a rail leg from the factory to the port, and it might be 300 or 300 kilometres, and then it gets put on a boat to Australia, which I think is around about 10,000 kilometres, depending on what port, I guess. And then it goes on an articulated truck from the port to a distributor. You can even go to this amount of detail. And then the last leg is, it goes in Tyler's light commercial vehicle for the last 10 kilometres to the site. So you can put however many legs of transport in you want, and we'll see the transport distance updated, or transport impacts there updated. So I hope that answers the question you had there, Amy. Has eTool been, the next question is, has eTool been used on GBCA performance rating building yet? And is it possible to align, compare categories and credits between eTool and GBCA? So that's the Australian Green Star system, Green Building Council of Australia. We have used eTool on Green Star projects. I don't think it's possible to align or compare the categories at this stage. GBCA have included life cycle assessment in their more recent releases of the tools, which is fantastic. That's also why we've developed the EN 15978 compliance. They're really so there are definitely elements about sustainability that aren't covered in eTool. So one of the blindingly obvious ones, and one that we're going to rectify at some stage this year in our product roadmap, is occupant transport, for example. So if you look at a building and its location and the facilities in the building, there's probably quite a few things that a designer can do to try and influence occupant transport, whether it be providing facilities for cyclists, providing facilities for electric cars for charging, also encouraging, probably a positive thing for occupant transport would be encouraging density in low density areas. So you've got a greater demand for public transport. I mean, these are pretty big, I guess, policy decisions, but we certainly want to tackle some of those in eTool, give the ability for people to model those. So we will be introducing occupant transport, but at the moment we don't have it. There are things in the Green Star tool that account for that already. So that's one area where the scopes don't align at the moment. Similarly, there's a lot of things that are probably more on, rather than being an environmental performance criteria in Green Star, they're more an occupant health criteria or a wellbeing criteria or a social sustainability criteria. And they're not covered in eTool. eTool won't ever cover social sustainability, I don't think, unless we build a huge bolt-on at some point. But so it's really an environmental performance package, not a social sustainability package. I guess eTool can also be used for life cycle cost assessment as well. It's not compliant with the international standards in that regard yet, but we will bring it into compliance in the future. So yeah, eTool really covers economics and environmental. Green Star covers some other areas, I think, that we're not going to cover. So I hope that answers your question, Daniel. No, I think I've got all the questions answered so far. Did anyone else have questions about eTool at all, or? Okay. Yep, we've got another one from Noy. For the renovation case, what would you use as a baseline to compare the improved design to? Well, eTool has a number of predetermined benchmarks. So, for example, our residential benchmark for Australia is it's a statistically representative housing mix or density mix of different buildings and different construction types. And also it represents the energy consumption that would be expected from a new home that's built to BCA compliance. So if it's a residential renovation, you would definitely compare it to that benchmark. And similarly for different building functions, there are some building functions or structure functions that we don't have benchmarks for yet. So an example of that, we're sort of in the process of developing a lot of these, but an example might be a supermarket. So we don't actually have a benchmark for a supermarket. People have still used eTool for doing assessments of supermarkets, and what they've done is built a BCA compliant version of their supermarket, which has the same functional area, etc. And then they've used eTool to model their building, and then they've compared their building to the BCA compliant building. You would do the same thing for the renovation if you're measuring some type or assessing a building that we didn't have a predetermined benchmark for that function. So another key thing to point out about the way we treat functional units in eTool is we see design life as a pretty critical element to the life cycle impacts of a building, and that's because materials, so those core materials that go into the initial construction, like concrete, steel, etc., if you can make your design last twice as long as it otherwise would by making it come under less redevelopment pressure, and I've got a whole technical article about that I'll send out to everybody afterwards, actually, because it's quite interesting, I think. Then you get twice as, if you can double the design life, you get twice as much function out of the same materials, and therefore the impacts per function are actually half. So it's very difficult to get a 50% improvement in your materials impacts through straight material swaps with different products. But definitely by improving functionality, it's a lot easier to get big improvements. So that would be quite important for your renovation, is to understand the design life, how much extra life you're getting out of that building due to the renovation, and then you apply that design life to those impacts, and then you can compare it accurately to the functional unit. Hope that answers your question there, Noi. Judith's just let me know. I think she's joined us from Europe, and it's 4 o'clock in the morning over there, so she's going to bed. Thank you very much, Judith. I'll catch you later. Any other questions from anybody? Another one from Daniel. What sources do you use for product information? Do product manufacturers supply information that has been third-party verified? So our main source of data is the Australasian LCI, which is effectively the peak body for or the industry body for life cycle assessment in Australia is called ALCAS, and they run a project called the Oz LCI. Unfortunately, the Oz LCI isn't fully comprehensive. It doesn't have all the materials that are required for your average building assessment. So we do draw on the Australasian LCI, which is effectively an extension of the Oz LCI, which has just got more data on it and it relies, I think, quite heavily on EcoInvent 2, I believe, which is a European data set to fill the gaps. But the energy sources, etc., have been oriented to Australia. So that Australasian LCI is the core database that we use in eTool at the moment. We're currently discussing with the different data providers how we can also implement their data into eTool. So it's likely over the next, hopefully 6 weeks, we'll see other data sources that you can select from. So if you're doing an assessment in a different country other than Australia, you should be able to select that the applicable database for that country moving forward. For specific products, we can actually enter data into eTool. What we would want, though, from that data is that it's compliant with EN 15804, which means it's automatically going to be compliant with the eTool methodology. And those reports or those compliant LCAs will need to be third-party verified in order to be compliant with that standard, that 15804 standard. So to answer your question, products that when we enter EPDs into eTool, yes, they will be third-party verified. There is a category in the materials. I'm just bringing this up on the screen now. Let me just find it. So in the materials categories, there's one called non-compliant data at the bottom, X non-compliant data. There's some EPDs in this that actually, or data in here, which aren't compliant with EN 15804, and some of these are actually product data, like these clinker blocks. So there's another one, this low temp clay bricks. So there's some different products in there that aren't actually compliant with 15804. We've still loaded them up into eTool, but we've made it very clear to users that want to select that it's not actually compliant data, so they have to, I guess, treat it with treat it accordingly, effectively, not hang their hat on it in terms of the results that they're getting. So I hope that answers that question about the data. Another question was, can we watch the recording later? Yes. For everybody that perhaps missed the start of the presentation, I'll post the recording online, and I'll distribute the link to everybody so you can watch it at a later date. I'll just put a note on that for myself. So are there any other questions? I should also mention that presentation was lightning quick. If you were confused going through that, I mean, don't worry. Life cycle assessment of a building is usually something that takes a month or something for your average LCA practitioner. eTool has made that a lot quicker, but even so, trying to cover a life cycle assessment in a building in an hour is just a ridiculously ambitious task. So if you got a bit lost during that, please don't worry. Perhaps watching the presentation again later will enable you to pick it up, or just get in touch with us and we'll give you more details. There's lots of help videos as well on the eTool website that should give you an ability to get through an LCA of your own. Okay, any other questions? I think I've answered all the questions there. Just let me know if I've missed anything. No worries. Well, thanks very much, everybody. We might sign off there if there's no more questions, and we'll hope if you've got other questions that come to you later after perhaps mucking around in eTool or looking at more of our services or whatever it might be, then just get in touch, and I'll post my email address now in the chat thing there. So there's my email address if anyone wants to get in touch and ask further questions. No worries. I'm going to put the microphones back on now, and if anybody, I think Daniel wanted to have a chat afterwards, so if anybody wants to chat, then we can do that, probably without having to use the chat thing. We can talk.
Oh, hi, Richard. Are you there?
Speaking, yeah.
Yeah, I can hear the feedback.
Yep. So I hope that made a bit of sense, Daniel. As I said, it was a pretty lightning quick demo. It's a pretty complex practice LCA. So don't stress out too much if that was, if some of that went over your head or you got a bit confused at points. Yeah, it's a pretty ambitious sort
it
of
was really
presentation.
Yeah, I felt it was really good. It was very clear, and it looks quite a logical process, and it's quite well laid out tool. So there's a lot of information in the database already there that you can pull down and draw on. So
yeah, the template library. That's the key thing is just letting eTool do the work for you. And you can actually also, I didn't go into this in this presentation, but you can clone templates from the library and adjust them yourself as well. So you can actually build your own templates if you like, or make the templates more applicable to your design quite easily.
Okay.
We've also got another service where if you're not sure about whether those adjustments that you've made are actually applicable or correct, and that particularly comes into play with things like operational energy templates where you're applying those more complex formulas. You can submit that template for validation. That's a free service. The reason we don't charge for it is we'll upload it into the public template library after we've validated it, so that everybody gets the benefit of that template. So it's, I guess, like we'll validate your template for you as long as you're happy for the wider eTool community to also benefit from the use of that template, if that makes sense.
That's fantastic. I think having that kind of open source approach just makes the library grow so much faster.
That's the idea of it.
People are input. Yeah, people are using it and sharing with it. It's great. That's a great idea. Yeah,
we've already got subscribers who are using that at the moment. We've been really, really busy recently, and we haven't actually even validated all the templates in our own library yet. So that's something that we need to tackle. And there's also an ability in eTool to assign references to those templates as well. So, and that would be an expectation of those templates that get submitted for validation, is we can actually refer to the sources of the assumptions, if that makes sense. That might be a design life assumption, or it might be a quantity assumption for how much timber's in a stud wall or whatever it might be. But we do need a source for that
but even like a product. When I was working with Kingspan, we were looking at getting the information, embodied energy for phenolic foam insulation, and we were going to go through EcoSpecify with their green tag certification, so you could reference to something like that where the source information's come from. But going back to that, it was quite difficult to get the information from the manufacturer, because a lot of the information is kind of classified. It's what's the word?
Like it's IP protected or whatever.
IP, that's it. Absolutely, it's IP protected. So it was quite difficult to get the transport, the materials, and all the ingredients, because it's industry secret as well. So
that's the so the way to overcome that. So that's really something that would happen outside of eTool. Like the way to overcome that would be ask that product supplier to do an EPD, and all their information stays private. The only person that sees it is the person that does the LCA, and also the third-party reviewer would also have access to the LCA report, which would document all those assumptions. Or the other thing you do is you could use an average value for that product, and then you could apply a factor of safety scenario to it, and say, okay, what would happen if we use sort of a worst case and a best case scenario, and just build a bit more knowledge around it. Now, if those different scenarios really had the potential to blow the to change the whole premise of the total EPD due to that one element of that final product or whatever, then you'd probably want to get some more surety around those different assumptions. But if you find that, for example, with a Kingspan sandwich panel product, if you find that the foam's only 5% of the total impacts, then it doesn't matter if it becomes 10% or 2%. It's still going to be a reasonably accurate, assessment for the whole product. So that's something else you can effectively do to, I guess, control the accuracy or the data. I guess, yeah. As long as the third party reviewer is happy with those approaches, then you should still be able to generate a good EPD for the product. But the other thing with that is, once you've done that full LCA report and had it certified, the only thing you actually have to lodge with the program operators is a summary report. So all your IP is still protected, and that's the only thing that becomes public is the summary report, which really just details the impacts. So that's basically the way that works. But with eTool, you're really working from products up, so you shouldn't have to know what's going on for the manufacturer. It's really about choosing their final product and then, or a generic product in this case, which is what 90% of the data is in eTool, and applying that.
Yeah, it's good to have those checks and measures. Some manufacturers might try and take advantage of a situation to gain a bit more traction in the market with their product against a competitor's product. You make fictitious claims. It's not unusual. So, it looks like eTool is protected from that. You've got some good databases, some European standards, some generic values, so you've got an idea where they should be anyway. So that's good to see. Yeah,
interestingly, we did so one of our subscribers, sort of advanced subscribers from Victoria, did an LCA recently on a Coles supermarket, which used a Kingspan product, or a lot of Kingspan products in it actually, and they had some LCAs that were conducted to the BPIC standard. So that's the Building Products Innovation Council. So they've got a set of protocols for life cycle assessment of products, and effectively they found that what they'd done it to that standard, so it's a different standard to EN 15978. What we did is we threw it into eTool in that non-compliant data category, I think, so that they could actually use that in the assessment. But what we found was that the difference between that and using the generic products in eTool was absolutely negligible. I think from memory, it was something like 64 kilograms of CO2 per metre squared versus 65 or something like that. So, it was within 5% error for the indicators that we had. So the Kingspan products, the data that they've got publicly available seems really robust from my point of view. Definitely.
Kingspan panels, which would have been the Kingspan panel product on the Coles. They import the raw ingredients and manufacture it in Sydney. Whereas Kingspan Insulation, which is another part of the group, their product currently is the phenolic foam products manufactured in Ireland and the UK, and then it's shipped down. So they will they are setting up a manufacturing plant in Victoria in the near future. But at the moment, you've got that shipping element as well that you need to consider. But it's good to see that that is such a close comparison. So you've got checks and measures to make sure the information you're getting is correct, and you're happy with it and happy to use it.
That's the reason. So they ended up using the generic data because the EP. That's one problem with the EPDs is managing the end of life scenarios. So most EPD program operators, it's really a cradle to gate assessment, and when you're using products like steel and aluminium, you actually get quite a good credit at the end of life for feeding it back into the economy, by recycling it. So they wanted to actually reflect that in the assessment. So they used the generic data, which enabled them to split the steel out and then gain the environmental credit at the end of life for recycling that effectively. So they ended up going for the generic data in eTool for that reason, and that's something that's a little bit, we're not 100% sure how we're going to deal with that with EPDs in eTool. Just depends on how well the new EPDs are going to be reported. Yeah.
And the end of life is a very difficult thing to predict. If you've got a building that's 50-year lifespan of 50 years, we don't know at the moment what technology will be available to recycle the material that can't be recycled at the moment. So it's a difficult thing.
Absolutely,
See why they choose cradle to gate for that reason.
Yeah, no, absolutely. So the way you have to deal with it in the current EN 15978 standards, you have to assume current recycling or end of life scenarios. Like you have to assume what's happening today will happen in 50 years, which I think is a pretty pessimistic take on it.
Yeah, absolutely.
But
that's the best you can do, isn't it?
Yeah. I think from that point of view, if you're claiming a credit, you're probably claiming a pessimistic one. So I don't think it's going to drive. I don't think it's going to drive bad. Or it's not going to drive poor decisions. Basically, I think it's probably still going to drive the right decisions, even if you're including that end of life phase. Yeah. I mean, if you're looking at utilising steel versus concrete in structure, and the cradle to gate stages are exactly the same, which would be probably quite unusual, but let's just assume you had two options and they were for structural elements. One was steel, one was concrete, and the cradle to gate was exactly the same. You definitely run with the steel because you can feed that back into the economy. If it was just an environmental decision, whereas concrete becomes road based, it's effectively a waste material that gets downcycled at the end of the building life, whereas steel's actually got value at the end of the building life to go and be used in another, either get fully recycled at a steel plant or even get directly reused in some cases as well. So I think, from that perspective, it's a really good idea to include that end of life phase. It's pretty rare when you're making a decision like that, but in the off chance that you are, I think it's quite important to consider that. Yeah.
Yeah, so one thing I'd like to do is take a multi-residential building and model it in concrete, steel, and timber, and see where the three come out. Yep.
That would be
one of the things.
Yeah. So because the other element to that would be how the thermal performance is going to change for those different buildings. So thermal mass.
That's right.
Yeah. Thermal mass isn't as important for commercial buildings, but residential buildings actually becomes quite important, particularly for a region like Perth, which has such good temperature range on an average day. You can usually benefit from some natural ventilation and storing a bit of temperature in the thermal mass. But there's no reason why you couldn't do that. You said you've been trained in NatHERS as well. Is that right?
Accurate, yeah.
Sustainability. So
and what we find is for Perth climate, insulating the thermal mass, so have the insulation on the outside of the building, is a very good solution. It's quite easy in Perth to design a building that doesn't need really heating and cooling, just natural ventilation, like you mentioned, and create an orientation to benefit from some solar gain, and just insulated well, and have thermal mass on the inside.
Yeah, my last house that I lived in was probably a 2-star house. It was just a really old house, and had heaps of glazing on the south side, and it was oriented north. Like the longest orientation of the house was north-south. Everything was wrong about it. Well, not everything. Like it still had eaves and stuff, but it wasn't exactly
Yeah.
good. And yeah, we didn't have air conditioning, and we didn't have we just had an open fire for winter, and that was all we had. And we survived. So Perth, you
Yeah.
probably wouldn't be the same if that house was sitting in Broome or Albany. So in really cold climates or really hot climates, it would be a lot more uncomfortable. But in Perth, it was fine. Yeah. So yeah, I reckon
Well, the
even
last
a
house we were in, we just
6-star
moved a
house
few
in.
months ago.
Yeah. Sorry, go ahead.
Yeah. I said that previous house we were in about 2 months ago had a lot of glazing on the east and west sides, and it was double brick concrete slab, and it absorbed so much heat through the day, and it had insulated ceiling which trapped it in at night. So the electric bill was quite high for the air conditioner. And now we've moved up into the hills, and we're in a brick veneer timber frame home which is built in the 60s, and it's so much cooler. We've just got an evaporative cooler which we haven't even flicked on yet, and we're not even running any heating at the moment. So
wow.
It's not got much insulation in the roof, but it's so much more efficient, and it was built nearly 50 years ago as opposed to the previous house built 15 years ago. So some builders have gone backwards in a big way, and this is north facing at the back, so I've just put solar hot water, and the PVs will be coming next week.
Cool.
So just the benefit from that. Yeah, so
that's awesome.
Yeah, I think the way the occupants use the building as well, we don't feel we'll probably need to flick any heating on anyway, because there's 6 of us in here and we're all pretty busy, and it seems to generate a lot of heat anyway.
Yeah. No, that's occupant behaviour is so critical. As I said, that was a 2-star house we lived in. I reckon if you'd actually run it through NatHERS, and we had ceiling fans for cooling, and we just had an open fire that we didn't even run all the time. We ran it semi, probably for those middle 2 months, probably at least every second night. But that was basically it.
I think what they've also found, a lot of the 5-star buildings that have been recently in the last few years being built actually only achieve 1 or 2 stars anyway, even though they're designed for 5. So there's a big compliance issue there as well.
Yeah, right. Yeah.
I think they run a check of compliance in Victoria just in the last 12 months.
Oh, really? Yeah.
It might have been CSIRO that did the study. So they looked at 400 newly built homes, and 98% were non-compliant with the building code.
Really? Is that more? Was it more to do with ceiling and stuff, or like window sealing and door sealing, or was it more to do with actually literally they didn't have the insulation in there that they'd said they would?
Well, they were looking at the whole of the building code, so fire, energy efficiency, the whole lot. 98% had non-compliance issues somewhere, and it just goes to show that the checking of the buildings, the surveying of the buildings, signing them off is not really happening in a lot of cases. This is where the designs might be great. They might be looking at 6-star in the building code, but what the builder actually puts in place might not, due to workmanship, things like that.
Yeah.
What you think you're buying, and that's why I see a big problem. But
it doesn't overly surprise me. But it's. I think if a building was 6-star though in Perth, I think even a 6-star building wouldn't require heating and cooling. I reckon it'd be pretty comfortable.
I don't think so. Yeah. That's where unfortunately you have people who have the heating on in the winter with the windows wide open, and that's the mentality.
Yeah. No worries. I might.
That's all good. I better
keep going. Yeah.
Keep going.
I
wonder if I could arrange to come down and meet you in person at some point.
Yeah. No, that shouldn't be a drama. Maybe lunch or something one day. Yeah. Just have a look at my calendar. So save that. So looks like I'm pretty free lunchtimes for pretty much tomorrow, Friday, Monday, next week. Otherwise,
Friday
it'll be
would be good for me.
so 2 days time, Friday, or next week. Yep. No worries. That sounds good. Just let me have a look at what this is. Okay. Yep. So if we can do it, if we can meet at 12, that'd be good because I've got a meeting at 2 that I have to be at on Friday. So yeah.
Yeah, that's fine.
No worries.
Just let me know where, and
yep, no dramas. I'll send you an invitation. Probably. Yeah. Sorry. Go ahead.
Yeah. Okay then. Yeah. That's fine. Yeah, I'm not actually sure where you're even based at, to be honest. Where?
Just in the city. Or... Yeah. In the city. Yeah. Yeah.
Okay,
in Perth.
that's cool.
Yeah.
That's fine.
No worries.
Yeah.
Rightio. Thanks very much. I'll catch you later, Daniel. Cheers.
Cheers. Thanks, Richard.
Bye.